Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In this session, we will be looking into the concept of splay trees. Under the splay trees, we will be discussing about what are different splay tree rotations. Okay. Now, first of all, we will look into what is a splay tree definition. Splay tree is nothing but another variant of binary search tree. As we have seen different variants of binary search trees. Those are already we have discussed AVL trees, B trees, and red-black trees also. And this is another variant, that is nothing but the splay tree. Okay, now we are going to discuss about this splay trees. What is splay tree? What is the use of this? The splay tree is nothing but a recently accessed element is placed at the root of the tree. Which of the recent element you want to access, that has to be placed at the root of the tree. And what is this splay tree is defined as? A splay tree is a self-adjusted binary search tree in which every operation on the element rearranges the tree so that the element is placed at the root position of the tree. Right? When you are going to do some operations like insertion, deletion, or searching, any of these operations if you are going to do, in that particular operations, it is going to rearrange the tree. It is going to rearrange the tree, and which of the element you are looking for inserting or deleting or for searching, that element will be placed at the root position of the tree. Okay, this will happen. And in splay tree, every operation is performed at the root of the tree only. And all the operations in the splay tree are involved with a common operation called splaying. Every operation in splay tree will be done at the root of the tree. Only on the root it will be concentrated. And the other operations if you are doing on that splay tree is nothing but splaying. What is this splaying? Splaying is nothing but it is a process of bringing a particular element to the root position by performing suitable rotation or operations. Right? To bring that particular element to the root position, we are going to do some rotations or performing some operations to get that particular element to the root position. Okay. Now let us see. By splaying, we bring most frequently, as I said. We are going to perform different operations on these splay trees. Based on that, we are going to move more recently or frequently used element closer to the root of the tree, so that any operation on those elements is performed quickly. If it is nearest to the root or it is a root node which I am going to search or which I am going to find for searching, in that particular case, it is very easy to access that element, right? That means the splaying operation automatically brings more frequently used elements closer to the root of the tree. That is the same. The splaying is nothing but it is going to bring the more frequently used element closer to the root of the tree, or it may become the root of the tree also. Right? This is nothing but splaying. Now, to perform those things or to get that element nearer to the root or as becoming the root of the tree, we need to perform some particular rotations. What are the rotations here we are going to do? Here mainly we are going to do rotations in splay tree or jig rotation, jag rotation, jig rotation, jag rotation, jig rotation, and jig rotation. Right? These rotations are similarly like our AVL tree rotations, as we have discussed in the AVL tree, but the names are little bit changed. Okay, but in avial tree we come across only two types of rotations we have seen. One is single rotation and double rotation. And in single rotation again you have LL rotation and RR rotation. In double rotation you have LR and RL rotations we have seen. But here we have two more different combinations we are looking into, that is jig rotation and jag rotation, right? Now coming to see about what is jig rotation, first you need to understand what is jig and jag rotation, so that the remaining will be related to that, zig zig and zag zag, zig zag, zag zig rotations. Now first we'll see about the zig rotation. Zig rotation in a splay tree is similar to the single right rotation in avial tree. Zig means right rotation, right? In zig rotation, every node moves one position right from its current position, right? From the current position, it is going to move one position right, right? Now, suppose I am going to consider this tree. In this tree, I am going to perform splay on these three. Splay on 3 means where we are going to perform zig rotation. That means it is going to move one position right. When 3 is moving to the top, automatically 5 will come down, right? Like this one. 3 is the root node where you can access this tree fastly, or very close we have placed it as a root node. We can access that particular node very fastly, right? This is a one. And when I am going to move down, automatically 2 will be the left child and 5 becomes the right child. And when you can see this part 4 is the right of 3, but I don't have the place to place 4 as a right child for 5. But what happens here? Okay, I need to check where is the correct position to place my 4. This is 5, right? 4 is lesser than 5, so I need to place it as the left child. This is jig rotation. Now what is jag rotation? Jag rotation in splay tree is similar to the single left rotation. Single left rotation in avial tree. Here also every node moves one position to the left from its current position. Consider the following example. Consider this is your tree. Now I want to move one left rotation I need to do from the current position. To do that, I am going to select an element called phi to perform splaying on that. When I am going to perform splay on 5, what happens? It is moving to the left of it. Now you are going to get 5 as the root node, 3 as its left of it, and 6 is the right child, and 2 is the left child for 3. Now what happens to 4? For 4, you have this, right? 5 left child is 4, but here 5 left child is 3. Now I need to make that as a right child to 3. Like this way, we are going to perform splaying. For jag rotation, zig is right rotation and zag is left rotation. Now here we need to perform zig rotation. Zig rotation in a splay tree is nothing but double zig rotation, and here we are going to move every node moves 2 positions to the right position from its current position. In previous case, we have seen only one right position we have moved, or one right rotation we have done. But here in zig rotation, it is going to do 2 rotations, right? Now I want to perform splaying on 2, right? Now first what happens? First it has to move to one position. What is the position it is going to get? I am going to get 3 here, then 5 here, 5 right is 6, and this is my 2. 1 zig rotation, right? And 3 right is 4, so I don't have place here to place it, so we are going to place it as this. Now again I need to perform one more zig rotation. Now when I am going to rotate this one, I am going to get 2, 3, 5, 6 and 4 like this. This is zig rotation. Now zag rotation is nothing but left rotation, double rotation. Double left rotation we are going to do. We are going to move 2 positions to the left from its current position, right? Now, according to that, now apply splaying on 6. Apply splay on 6. When I am going to move left rotation on this, what I am going to get? I am going to get first 5 here. On right of it, it will be 6. This will be 3, 2. Now on right and left of 5 I have 4, but on left of 5 I have 3, but it has to be placed as the right of 3. Why? Because it has to satisfy BST. Now again I am going to perform splaying on this. When I am going to perform splay on this, one more left rotation. Now I am going to get 6, 5, 3, 2 and 4. This is my tree where I am going to get it. Next, zigzag rotation. Zigzag rotation in splay tree is a sequence of zig rotation followed by zag rotation. As you know that zig rotation is right rotation and zag rotation is left rotation. That means here we are going to apply 2 rotations, right and left rotations. Every node moves 1 position to the right first, followed by 1 position to the left from its current position. Now observe. Now I am going to apply splaying on 4, right? This is R and this is L. Okay. Now I am going to apply splay on 4. When I am going to do this, on left I am going to perform first right rotation. When I am doing the right rotation, how I am going to get 3? This will be 2 as it is. When I am moving 4 to the right, I am going to get 4 here, 5 here and 6 here. Like this way, the same 3 I am going to get. Now perform, already we have done right. I need to perform the left rotation. On this, I need to perform the left rotation. When I am doing the left rotation, I am going to get the tree like this. 4, 3, 2 and this is 5 and 6. Like this way, the same tree I am going to get. Right? First we are performing the zig rotation is nothing but the right rotation, and then zag rotation is nothing but the left rotation we are going to do. Right? This is zigzag rotation. And the last rotation where we have is zag-zig rotation. Zag is left rotation and zig is right rotation. Here also it is a sequence of zag rotation followed by zig rotation. In zag-zig rotation, every node moves 1 position to the left followed by 1 position to the right from its current position. Now consider the following example. This is the example where we have. Now perform splaying on 4, the same. But here you have LR. Now first, which rotation we need to perform? We need to perform rotation. We need to perform rotation of right. Right rotation we need to do. When I am going to do right rotation on this, what tree I am going to get? 5, 4, 3 and 2. This is the right rotation. Right? Now perform zig rotation. Zig rotation on this. Here you have, right? Zig rotation on this. Zig rotation at 5. What I am going to get? I am going to get 4, 3, 2 and this is 5 and 6. Like this way, I am going to get the tree. This is nothing but the zag-zig rotation. Okay, the same has been repeated. Now, you can see the summary what we have discussed under this splay trees. We have discussed about what is splay tree. Splay tree is nothing but it is another variant of BST where we can place the most or frequently used element to the root. To get that recently or frequently used element closer to the root, we are going to perform the splay tree rotations. As we have seen 6 different rotations we are going to perform under this splay trees: zig, zag, zigzag, zag-zag rotation, and zigzag rotation and zag-zag rotations. Right? These are the rotations where you are going to perform under split wrist. Yes, I hope you understand this concept. Thank you.